Hello, this is Jenna Nelson, and I am presenting my course project for GISC 510. My project is Coastal Changes for Piping Plovers, examining critical beach habitat in Maine. Historical shoreline change analysis has shown that the beach in Phippsburg, Maine has had more long-term erosion than any other area in northern New England. This area is also one of about a dozen sites in Maine suitable for the endangered bird species known as the piping plover. One of Maine's longest and least developed beaches, this area at Popham Beach State Park has been designated by the Maine Department of Inland Fisheries and Wildlife as essential habitat for the piping plover. The purpose of this project was to use GIS processes to examine this habitat area for further signs of coastal erosion. High-resolution imagery and elevation data from 2009, 2011, and 2018 were processed and compared for analysis. The methods portion of this project can be divided into three main categories: land cover classification, vegetation analysis, and change in elevation. Land cover classification began with looking for the high water line. The high water line is an important marker for sensing coastal change over time and can be obtained by digitizing wet versus dry sand areas at the beach. Since piping plovers need dry sand areas to nest and feed, delineating and measuring these areas was an important first step for this project. High-resolution NAPE imagery was obtained for 2009 and 2013, the widest span of years available. Using supervised pixel-based classification, 4-band imagery including near-infrared when possible, the study area was classified as dry sand, wet sand, water, and vegetation. These images provide a snapshot of how the landscape has changed over time. A more thorough study would average together many sets of data over the years, using high tide imagery whenever possible. Here we can see the natural color imagery, the near infrared, and the pixel-based classification result for the 2018 imagery. The next step was a vegetation analysis. Calculating a salt marsh edge by image processing, MEIP, is another way to process data for evaluating change over time. The MEIP method looks for the vegetated/unvegetated line. In this study, the Normalized Difference Vegetation Index, or NDVI, was calculated for NAPE imagery using bands 4 and 1 to remote sense vegetation. Positive NDVI values were extracted by attributes for imagery from 2011, not 2009 due to lack of band 4, and 2018. These two outputs can be compared to look for change in vegetated areas. Here you can see the earlier 2011 compared to 2018 and how there's been an overall decrease in vegetation or vegetation health in the area. The final step in this study was an elevation process. Comparing remotely sensed elevation data is another method for analyzing shoreline change over time. Lighter point cloud data from 2011 and 2018 were downloaded and LAS datasets were created. The LAS datasets were converted into rasters, selecting only ground returns so as to create a digital terrain model. The 2011 raster was subtracted from the 2018 raster so that negative values signify decrease in elevation or potential erosion. Positive values represent accretion. And here you can see again, the major erosion areas are going to be red. I've chosen to use a percent clip in this symbology. So these are not minimum maximum values. Some areas were actually even more erosion. Finally, for results, I have several maps we'll look at. First, the land cover comparison. Comparing 2009 to 2018, I've extracted the dry sand areas so you can see exactly which areas of the beach that might be nesting areas for the piping plover have changed or moved over time. We can see a lot of activity over in the mouth of the Morse River, where an entire sand spit has relocated. Again, pink being the earlier time imagery and blue being later. And also a lot over here at Honeywell Beach. Here we can take a closer look at the vegetation. Again, this is still the pixel-based image classification with the older imagery here, looking at actually a residential area of the beach and how this area has changed over time. We can see the vegetation line retreating, and this area has also changed significantly. And here is the NDVI results. Again, on the left being the earlier imagery. Here we are again at the mouth of the Morse River. And if we compare it to the later imagery, see a lot of vegetation here has been impacted. Finally, let's take a closer look at the change in elevation using the LiDAR data. Again, the major erosion areas are in red. Over here at the river, major changes in the beach area of the state park, and this stretch of Honeywell Beach. These results show that although significant changes have occurred in several distinct sections of the study area, there still remains a significant suitable nesting area for the piping plover in this region. The area at the mouth of the Morse River has undergone tremendous change, including the movement of a large sand spit. One of the major erosion areas is adjacent to the state park, near residential buildings on Honeywell Beach. Park officials and residents should continue to take steps to preserve remaining vegetation for the piping plovers, and the areas should continue to be monitored routinely. These processes can be transferred to other essential beach habitats to look for evidence of erosion. Both essential species habitats and human-developed or residential areas should be consistently monitored for change in case protective measures are needed. Here are my references and data sources, and I thank you for watching.